Okay, so I was talking about. Okay, let me start afresh. Hi, this is Dan here. A little bit rugged today, but I said let me just create this video, and this like my first time. Sorry, let me adjust this face reveal kind of thing, and what do I talk about today? I want to talk about share my experiences, my wisdom and knowledge, share with the world, especially with data science, machine learning, technical stuffs, and just being a beacon of hope for anybody who is trying to move from a certain stage in their life to another. So, for instance, if you're a non-technical person trying to exit, trying to move into a technical role, just seeing me or seeing this channel and knowing that hey, it's possible, you could learn stuff, you could do stuff, you could build stuff. So I had this experience recently where I was trying to hustle a job, right? So I got invited for an interview, a technical one, and then I was given a very basic machine learning lifecycle project. So I was given a bunch of data sets, and then I was told to create a model, a machine learning model that could perform at a certain level of accuracy, 98% accuracy on the test data set. So if you don't know anything about machine learning, well, what usually happens is you get an algorithm from one of these libraries in Python or R, and then you train the algorithm on a training data set. A training data set is broken into two variables. The first are attributes that are independent, and then the final variable which you're trying to predict, which is dependent. So in that case, you could say you want to predict a salaries, right? Salaries of software engineers. So you could get records, surveys, and all that from engineers and then you get attributes like their age, their gender, their location, and then all of those variables you collect will be independent or predictive of the salary variable which you collect. So the guy in San Francisco, the guy in Kenya, the guy in Nairobi, the guy in Lagos, how much do they earn? And then these other variables. And then you take that data, you break it into two sets, the training data set and then test data set, right? And then on the trained data set, you pass in this algorithm depending on the type of independent variable you're trying to predict. So salary, for instance, is a continuous variable. What continuous means is it could be a 10.17, a 100.71. It floats, right? It's numerical, quantitative. So for instance, if we were predicting something like classes, things that are categorical, that are qualitative, right? There are different algorithms for that. So but in machine learning, essentially you take that, you break it into two, training set and test set. Test set usually does not have the predictive value, the independent variable. Or if you have it, you're just using it to evaluate if your model works well. So you take your algorithm, you train it on that training data set, and then when you have the result, you could take that model itself and then use it to predict on future sets, right? You could take that test set without the independent variable, so it just has the other dependent variable like sex, gender, location, all that, and then predict. So this was the exercise I was giving, and I didn't do well. I was so surprised I didn't do well because maybe, I don't know, I was anxious or wasn't practicing enough. I think the problem was I wasn't practicing enough. So for this video, I'm going to try and replicate that same exercise. I was given 30 minutes to carry out this exercise. So I'm going to put on my timer, share my screen, and then let's see what happens, whether I'm good enough or whether I can actually do that or not. So I must say I practiced again, and yeah, let's start. So I'm gonna timer, and then we'll just go. All right, so I want to set my time for 30 minutes. Oops, sorry. Right, so I want to create a timer here. I want to set it to 30 minutes. Yeah. Yeah. Save. Okay. So I'm just going to start it now. I'm going to set up my VS Code and all of that and just start. All right. So my time starts now. What I'm going to do next is launch my VS Code. All right. So I'll take. Bring that here. I want to create a new Jupyter notebook, right? Create a new notebook. Okay, so I'm going to create a new notebook. Oops. Okay, so I created. Going to set up my kernel to my Python, and then I'll just come here and get the path to the data sets I'm supposed to use. Okay, so we're just gonna come in and there's the full part. I don't really need to do much here. I just need to list all the files in this directory. Okay, so if I run this, I get all the files. And the next thing I want to do is import my libraries. Import libraries. And in the assessment, I was allowed to do Google searches, and it's such a seductive thing because what you end up doing is you end up wasting time. I don't see why you will be plotting graphs in an assessment, but let me just import that and import my Seaborn. Then for my ML libraries, I'm using sklearn. So I'm saying from sklearn, my data already has, it's already split, so I wouldn't really need to split records here. So I'll just, from linear model, because I'll be using a linear model, just to create a baseline. So I'm gonna have my linear regression, good, logistic regression. Logistic regression is for when you're dealing with binary outcomes, yes, no, 0, 1, tall, short, boy, girl. And then I'll need to evaluate my metrics with, from this library here, I'm importing, I think there's classification reports, good, so I already have that there. And then root means squared error if I was dealing with continuous values. What else do I need? I think, yeah, and I need something for scaling my values. So I will need it's in pre-processing, I think. I need to import a standard scaler. Okay, standard scaler, and then that's it. Next thing I want to read in the values. So I'm reading the train df1. So I can see a couple of values here for the train data set. So I'm just gonna import them separately. So I want to import, so I want to copy this here. I could call this a parent directory, so I don't need to quote so much every time. So I could just say parent directory plus this, and then plus so let me get this first. Yeah, okay, let me just put it this way then. Okay, let me see what that looks like. Remember, time is ticking. I've got just 25 minutes left. I want to view this. Let me see what it looks like. So I'm hitting some error. Here. What am I doing wrong? Okay. Let me see if this works correctly. Alright, to do this work. Still getting the same error. Okay, let me comment this and then run it again. Okay. But that's the directory. Okay, let me change the forward slashes to backward slashes and then see what happens. And change. Oh, okay, no issues. Oh, so these are the little things that just eat out your time. Imagine if you have to also do Google searches while you're doing this. So you got to practice, right? If you're trying to switch jobs, if you're trying to do stuff, you just got to practice like you're doing the real thing, you know? And just give yourself that chance of knowing that you've actually tried your best. Okay, so I'm just gonna take a parent directory again and then bring it here. Let's see what happens. So that works. So next, I'm gonna change this to info, right? I think the thing that just joins both of them together is the ID column. So there are some values here that aren't in the info bit. So this is gonna be test. Sorry, this is gonna be train. And then use Ctrl Alt to select multiple things and change this to info. Then I want to do a merge. In Pandas, you do a merge with. So I'm gonna say train df, merging the two things together. You're gonna do a PD merge from the Pandas library. It's gonna take train df1. It's gonna take train df1, train df2, and it's gonna be on ID. Let's see what happened here. Right? Let's see if that works. So it should work. Oh, it didn't work. Okay, I think it's supposed to be called key. Let's see. Oops, what did I do? Let's see, let's run it again. Oh, okay. Okay, so I just ran a search and there's no need for the square brackets here. Let me run it again. Oh, key. Okay, supposed to be on, right? So you see the attributes are longer now. All we need to do is repeat that for test. We've got 20 minutes left. Okay, I think I can finish before time. Yeah. So remember guys, practice. Now that we've got that, we want to change all of these values and then do some wrangling. Wrangling is usually the most time consuming bit, and if I were to do a train df info, what would happen is I would see, okay, I've got very little missing values, so I'm gonna start by making a copy. I'm gonna say train equals to train df.copy. Let's copy those files. I'm gonna drop all NA values. Drop NA. I think that's that. And I'm gonna want to replace the values in this category items, categorical items. So for df in train df select dtypes objects. Okay. Okay, so we're going to replace these values here. So all I need is my cholesterol. I need to put those values here. I'm going to call them replace values. This is glucose, because they all share the same terminologies. Say glucose. What else? Okay, just these two, I think. Yeah, just these two. And then I'm gonna say for, that's the way I have it here. I'm gonna say replace calls. I'm gonna say train calls equals to train calls train calls replace then I'm gonna put them in a map. I'm gonna say low. Oops, I've got 15 minutes left. Medium. And then high equals to 2. And then that's gonna change them. And then I'm gonna say the same thing, but for gender is gonna be a bit different. I'm gonna say F female Ceres M1 and then for these values I'm gonna say train pressure 1 equals to train pressure string splits expand equals to true, right? I'm going to max that with a PD2 numeric, so we really have numeric values here. So this is going to take the first value, it's going to take the second value, turn this to 2, and then let's see, train and P. Oops, we get an error. Drop any. Oops. Okay. I think it's drop any without the underscore. Ooh, so we did well. So I will just make this into a function. I'll say clean df train. Yeah. Oh we're gonna call this df, right? I'm gonna just take this and place it here. Let's place it here. So I'm gonna say, so that's gonna return. So they are obviously better naming conventions, but let's just go with what we have. Equals to clean df, train df. Let's see if that works. Df, train that. Let's see. It should work. Okay, it works. So another thing we could do is just to wrangling function on. What we need to add to it is to drop some values. We have to drop some columns. So we're saying we're dropping the ID column. We don't need it. We're also dropping the pressure column. We don't need that too. We're dropping that in place. Okay. That's it. So you can just move ahead to model development. We have like 10 minutes left. But before we even move on, okay, let's consider this. So one thing we want to do, we want to split it into a dependent and independent variable. Dependent variables are called X, usually called X. So in this case, we want to take train and then drop the diabetes column, yeah. Then Y, we wanna keep the diabetes column, yeah. I remember these are all in pandas data frame. It's called df train, sorry. So again, Control Alt to select multiple items and just replace. But before we do that, we want to scale the values, because if we did a Y value counts, you see that it's not evenly distributed or even closely distributed, right? So you can see it's heaped. It's going to be an overfitting problem. But so what we could do is we don't want to touch the Y variable. We want to adjust the independent variables, really. So what we're going to do is we're going to call a scalar. We're going to call the standard scalar. We'll call from pre-processing. I'm going to call that value, and then we're going to scale our X, which contains the independent variables. Scale, we're going to say, what am I doing? I'm going to say, I want to create a new pandas data frame. And that pandas data frame is going to be S. We're going to say, okay, X. Oops. I'm going to say X scaled scalar. We're going to fit transform. Fit transform is different from transform. X. Sorry, so we're going to remove this here. Yeah. Then we're going to say, we're going to fit transform, and then we're going to say columns will carry X columns, the same names as X columns, and then we're good to go. Let's see if this runs properly. Oops, convert string to float. So we need to run this again so that we'll have just numerical values, and then let's run this again. 10 minutes. Ooh. So what we have here is a binary thing. So we're going to use the logistic regression. So let's just call the algorithm logistic regression. We're not going to add any parameter to it yet, but if we wanted to check out for kind of parameters, you could just use the L function and then do this logistic regression after you must have imported that algorithm. So you could add you could swing all of these parameters. All right, so now that we have that, we're gonna just fit it. I'm gonna say model log R model equals to log R fits X scaled to Y. Let's see if that runs properly. Now we have our model. So we did print log R, and usually standard practice is that you set a seed to maintain any randomness. So now we've got a model. So we're done with model development. Now we want to evaluate our model on a new data set that it was not exposed to during the training phase. So what we're going to do here, let's just call this model evaluation. Now what we're going to do, we're going to take this function here that we use to clean our data set. I'm going to call it here. This time I'm going to call it on train. Right. Let's see, you shouldn't have an issue here. So it works well. And then now we're also going to do this, but instead of, so I'm going to show you what I'm going to do here. So we're going to do this. So instead of let me just change this to test. Y test. Change this to test 2. Test. So we've called this already, so we don't need it. And we fitted it already, so we have it fitted. Just the same way we fitted our regression algorithm. So instead of fitting again, we're just going to transform X based on what we fitted. So it has taken an image of the original values, the trained values, created a fit that makes sure that it goes in a normal distribution. And now it's going to take that same fit, imagine it as a skeleton now, and then place it on the test frame. So instead of fitting again on the test frame, it's going to take what it has normalized on the train set and then organize it on the test data set. So you could read more on it, the difference between fit transform and transform with scaling, standard scalar from the scikit-learn library. So we're going to do that here. We're going to call this X test scaled, and then what we're going to do is we're going to predict, right? With that. Since we fitted our model, all we're going to say Y test prediction. So instead of fit, we're just going to predict S test scaled. And then we're going to have a look at it. Okay, so I think we could do something, we could do it once a time, I think. Oops, I keep doing that. Okay, 5 more minutes. So you can see it predicts, right? 0 where absence of diabetes, 1 presence of it. So out of 10 we have, okay, sorry, should I 0 to 10? So out of 10 we have a single case of diabetes. I don't know whether it represents that same distribution we saw earlier, but so what we're going to do next is create a classification report. We're going to say classification report. We're going to take Y test, Y true, which is our Y test, and then the Y test prediction. And then we're going to print the report. So it's usually best to have this in a different chunk so that because of that little difference in the randomness introduced, we maintain it. And then we have a consistent report. So that's what I'm going to do. I'm going to move it to a different chunk. So I'm going to run this again. And then paste this here. And then we should be able to, we have 5 more minutes left. Oh, something is wrong. Inconsistent. Oh, what is wrong? Okay, a minute. Sorry. So I had to go quickly check something. That doesn't happen in a real life interview. So we're having inconsistent values. I'm trying to see where I went wrong. Okay. So it should be, it should come from our test set. That's why we're having this issue. So in this case, we should just check our classification report on the test values. And so I'm gonna run this again, yeah, and then we should see something when we do this. Okay, ooh, a 94% accuracy, which is cool. And then, so let's check what we could do here, and then see what parameters we could possibly tune to get better value. We have just 2 minutes left. So we could change the penalty from, by default the penalty is an L2, so we could change it to elastic net, penalty to elastic net. So let's just do that. So elastic net, okay, and then what else? Okay, let's keep it. Let's give C a 2, 3, 4. Let's give to 2, 3, 4. Okay. Let's make an intercept scaling a 100. What else? Class weights. Oh, I don't know what class weight will look like. Okay, let me make it balanced. Although it isn't balanced though, so let me remove that. Yeah, so this could make a difference. Let me put this here and then just run it. Live linear, let me go with live linear. What's default here is LP. Okay, we're running out of time, but let's see if this makes a difference. Let's see if this makes a difference. Ooh, value error. Okay, it's not value error because I use a double quotes. Okay, I'll change this to Saga then. Sorry, I have just 1 more minute. It's throwing errors. Run. Let me just put this here, then run again. Oh no, that type is gone. What could be wrong? So I don't know. Anyways, that's how you create a baseline model. We're not able to get to 0.94 in time, but this is how you could practice, how you could get yourself in your headspace of how a model lifecycle works. Comes from generating a record, importing them, cleaning them, passing them into a machine learning pipeline, getting the outputs, evaluating those outputs. And I hope that works for you. Hey, go build something cool. Today I'm going to share the links to all of this. Yeah, it's proprietary data, so I'll just create something fictitious for you to use. And yeah, just go build something cool today. If you watched up to now, 30 minutes plus, I really appreciate it. Like, subscribe, hey, make it happen. And more videos like this. And cheers. Build something cool today.